Can artificial intelligence systems teach a robot to spin a pen better than you? If you're familiar with AI's past exploits, you'd be open to the idea that it might be possible. Remember when the Go master, Lee Sedol, lost to AlphaGo in 2016? The AlphaGo AI won the game with ingenious moves that a human player wouldn't have imagined in their wildest dreams. And now, engineers at Nvidia are working on a project that explores the possibilities of training robots to perform sophisticated finger movements using AI, and they've struck gold. They discovered that ChatGPT's out-of-the-box thinking capabilities can be exploited to teach robots how to do subtle, complex tasks with robot fingers. In this video, we'll be showing you the wonders of the new AI model Eureka, which is an acronym for Evolution-Driven Universal Reward Kit for Agents. The news first broke on Twitter. Dr. Jim Fan posted a tweet on his official Twitter account where he highlighted and summarized the general idea behind Nvidia's Eureka AI. Although the tweet was quite technical, we can still take note of some key highlights amongst all the geeky jargon. For one, Eureka is the backbone behind the success of this project, and to understand Eureka, we need to know the challenges that prompted its design. While on the quest to develop robot trainers that can teach humanoids how to perform intricate tasks using fingers, the Nvidia engineering team stumbled into some hurdles. They found that established large language models are good with mid-level tasks that require only a few motors, like grabbing objects, and were even better at higher level functions such as planning. However, when it came to lower level actions that required several actuating motors to execute complex movements, the robots fell short. When it became clear that the issue was a gap between high-level reasoning and low-level motor control, Nvidia created Eureka to bridge it. Eureka houses a simulated reality called Isaac Gym, where robot AI models receive reinforcement training and learn how to perform complex, dexterous functions. Reinforcement training is a way to teach artificial intelligence systems to learn through practice. I'm sure we're all familiar with how ChatGPT gets better at answering questions as we use it over time. It does so by using your feedback to gauge the effectiveness of its results. By plunging an LLM into a virtual learning environment, you can take it through a wide range of tasks infinitely. If you look inside Isaac Gym, you'll see robots doing all kinds of activities. Here, we have countless dog robots walking around aimlessly. And this is a robot arm turning a knob or screwing a nut. We have these human-like shapes charging toward the screen, which look like they are rioting. These are robot arms flipping around a Rubik's Cube. The goal here is to get the color on top of the Rubik's Cube. Once the robot gets the correct color, it changes immediately, keeping it in a loop where it constantly tries to flip its cube to match the reference cube. Another fascinating thing about this training technique is the fact that it isn't task-specific. It is an open-ended training field where your robot can learn anything. The learning program depends entirely on what task you want to equip your robot with. Additionally, Eureka hastens the learning process by running it through an accelerator that can speed up simulated realities 1,000 times. By going through different tasks again and again, the robot model learns the best way to get each one done. Using this novel reinforcement training technique, Nvidia was able to develop AI systems that allow robots to perform complex, high-level motor control functions like spinning a pen around their fingers. Nvidia designed Eureka AI using PyTorch, a machine learning framework designed by Meta. The codes were written in Torch script, a subset of Python that allows you to serialize code. Let's look at Eureka AI's architecture so we can understand how it works step by step under the hood. It all starts with the user's task description. Next, it generates a code for executing the task. The coding LLM takes that code and modifies it into a reward function. That way, the robot hand learns to approximate the movements requested by the user in the task description. The reward function is fed to the GPU accelerated environment, where it repeats the task infinitely and finds the most optimized way to perform it through reinforced learning. And the GPU accelerated environment in this case is Nvidia's Isaac Gym. It speeds up the process so a learning timeline that would have taken years is completed in a few days. Isaac Jim takes the new and improved reward function, which is called the reward reflection, and it feeds it back to the code LLM, and a loop is set up at this juncture. ChatGPT generates a better reward function at every iteration till the system is completely optimized. Eureka designs reward codes across 29 open-sourced reinforcement learning environments, each equipped with 10 different kinds of robot morphologies such as quadcopter, manipulator, biped, quadruped, robots with sophisticated arms, and others. Eureka broke one of the biggest roadblocks in artificial intelligence. Large language models, LLM, have achieved some incredible feats. Yet, developers in this fast-growing field have been trying to figure out how to engineer AI robots that can perform dexterous manipulation tasks that require complex motor control functions like pen spinning. Pen spinning is the act of rotating a pen around the fingers in a specific orientation for multiple cycles. Eureka is responsible for the first simulated robot finger spinning a pen. Simple as this function seems, it is a big deal since manual engineering couldn't cross this bridge. We've said a lot of good things about Eureka and have a fair understanding of how it works, but does it actually teach robots better than humans? The short answer is yes. Expert prompt engineering can work wonders with LLM's console, but Eureka's creativity puts it past even the best prompt engineers. They carried out benchmark tests on the AI model to evaluate its teaching skills in comparison to that of a human, and Eureka crushed it. They tested it with different tasks, and it performed better than humans 83% of the time. On average, that makes it 52% better than existing robot AI models. The idea of reinforced learning isn't new to the AI space. Large language models have been bragging about developing models that automatically improve themselves based on human feedback over time. However, there isn't always a straightforward path for an AI system's learning curve. Besides, this kind of continuous learning process can be very expensive from an economic standpoint. The iterative programming in reinforced learning can cost a lot of storage and computational resources. By using a gradient-free learning approach, Eureka AI avoids the hurdle of taking a straightforward path toward perfection, saving costs and resources. It achieves gradient-free learning by leveraging human feedback to improve existing reward functions. The large language models we have today excel at solving tough sequential problems like making control decisions in real time for self-driving cars. Other problems that require sequential decision making are playing a card game, managing a stock portfolio, and playing chess. On the other hand, getting LLMs to facilitate low-level but more complicated tasks where a robot moves several motors simultaneously has always been a pain for AI developers. Nvidia's novel robot training program is a real Eureka moment for the AI universe. Don't forget to leave a thumbs up and subscribe to the channel for more informative videos about artificial intelligence.